Back in a time known as the 1980s, everyday people started to buy into the home computer. Many wanted to try programming, and all the popular models came with BASIC as a language. Computer magazines were popular and would contain program listings you could type in, either to learn about programming or in the hope that you could recreate the arcade game experience at home, often with disappointing results. These days you can emulate these old computers on your PC, often with all the extras you couldn't afford back then. And, if you like the original physical machine, you can have the best of both worlds. This is my BBC Master. Acorn designed it so you could add an internal second processor to speed things up. Today, that second processor can be a Raspberry Pi. It can emulate a whole range of processors from the 80s, but more than that, it can run in native ARM mode at 1.2 GHz. And, in a previous video, that led me to write an Asteroids-like demo in BASIC that ran as fast as an arcade game. Shoot-'em-ups were the big arcade craze of the late 1970s and early 80s. And the BBC Micro had a good range of these that you could buy. Of course, they were all written in machine code so they could run fast enough. There's no way you could do this with interpreted BASIC. So what I want to do is recreate the shoot-'em-up format, but using BASIC and vector-style graphics, which work well in games like Meteors and Elite, and won't require me to do any direct memory access to the screen. BBC Basic provides some simple line drawing functions we can use. The good thing is that the drawing behaves the same in any graphics mode, high-res monochrome or low-res colour. The pixels are bigger, but in the same place on the screen. My game is going to have the classic design. A rocket at the bottom of the screen is controlled by the player. Aliens appear above and fly around menacingly. You can shoot them and they can shoot you. If a shot is successful, then something explodes. We're going to have to store some data. The first thing I want to have is a graphics definition, how to draw something. There will be one of these for each type of actor in the game, and it is really just a list of drawing instructions. The entity information represents what each individual thing in the game is doing. I want to have a general structure containing the type ID, the size of the data, a pointer to its graphics definition so we know how to draw it, its state, colour, position, some data to help with collision detection, and any extra type-specific data. A game engine loop will control all the entities and manage things like the score and lifespan of everything. This is the ideal end state, but we'll go through some iterations before we get there. We'll need some functions to handle these objects, which will just be structures in memory. For the graphics definition, we'll want to build the data from a list of lines and then render the finished shape on the screen. For the entity information, we'll want to create a new entity and initialize it with some data and move its position in the game. We also want to iterate over all the entities so we can work with them like a list in memory and work out if they are in collision with another entity. I'm going to have to design the characters in my game. I've got a nice A4 square paper pad and a pencil to design a simple rocket shape. Now I need to translate that shape into a series of lines drawn between coordinates. I tried to do this in a reasonably efficient way to minimise the number of drawing instructions. Back at my BBC computer, this is my function to add an image part into memory. You pass in the address, a type ID, which describes what we're going to do, move, draw or stop, and X and Y coordinates. The next 3 bytes are populated with that data. And then we return the next address because you're going to do a few of these one after another. Next, we need code to draw an image part, so this takes one instruction from our graphics definition and works out what to do with it. We pass in the address of the data, and where on the screen we want to base our drawing. We then look at the first byte to see what we need to do. If it's a 0, then that indicates we've finished the drawing, so just return 0. If it's 1, then move to a point. If it's 2, then draw a line to that point, taking the relative coordinates from the second and third bytes in memory. Finally, as before, we return the address of the next item so we can do a load of these one after another. And that's exactly what we need to do to draw a whole image. The draw image procedure iterates over all the image parts and calls our draw image part function until it comes to an end marker. And here we have a function to add the rocket image I drew out earlier. We pass in an address in memory, and then each line adds an image part to either move or draw a line. At the end we just add a 0 and the draw image procedure will know it has to stop. Finally we return the next free address in memory. And here I've done the same thing for an alien shape. Now we need to allocate some memory for our images and call the add rocket image function, passing in the address of the start of that memory. And we can do the same for an alien image definition. Finally, we call the procedure to draw an image, once for a rocket near the bottom of the screen and once for an alien near the top. If we run the code, we see a ship and an alien. I've also printed the addresses of the start and end of the definitions in memory. We need to have some interaction between the human player and the game. I'll set up some variables for rocket and alien positions on the screen. And here we have the start of our game control loop in a repeat until block. I draw the rocket and alien, set a new rocket X position based on the current position, and adjust it if the player presses Z or X. Star FX19 waits for a screen draw so we synchronize our loop with the screen refresh period. Then if the new rocket position is different to the old, we delete the rocket image at the old position by using the background color before updating our position variable with the new position ready for the next loop. Here it is in action. As you can see, on a standard BBC Master it runs quite slowly. If we run it using the fast 65C102 coprocessor emulator, it's much better, but still not really up to gaming standards. We're going to want to draw more on the screen than just one rocket and one alien, which causes us some problems on a standard machine. Firstly, we need to allocate memory for our entities as well as more code. On a BBC Master we can solve that by using mode 128, which gives us mode 0 resolution but uses shadow RAM, freeing up 20k more for basic. Now we see problem number 2, it's far too slow when we draw many things. It's now we bring in the big guns. By using our pi-second processor's own video output, we dramatically increase the graphics performance and the picture quality. We can also use the native ARM performance while still using our BBC Basic code. And we get a hell of a lot more memory to play with. Now the aliens draw instantly and we can move our rocket around very smoothly. We've got this code to allocate memory for our alien entities, and here's some similar code to allocate and initialize some bullets. We have a function to set a bullet at a particular address with a state and initial position. We also have a function to update a bullet, passing a pointer to its image definition and a speed. The function will move a bullet up or down on the screen if it's active. I'm going to use a can fire flag, which I'll initialize to 0 here. Inside the game loop, we add a for loop to draw and update any active bullets. If the users release the fire button, which is the return key, then can fire is set. This forces the player to release the key between shots. Then, if the player fires, we set a new bullet at the next bullet pointer to the position of the rocket, get a pointer to the next free bullet entity in memory, and clear the can fire flag. Finally, we check if our next bullet pointer has gone out of bounds, and if it has, reset it to the start of bullet memory. And here we are shooting like a crazy lunatic. If we also make the aliens move around, it starts to look a bit like a game. But there's an important element missing. In this version, we can see our bullets are now hitting aliens and causing an explosion. That's done in this check alien collision procedure. We say that an alien status of 0 equals dead and less than 20 means it's exploding, so don't bother checking if it's in contact. Otherwise, iterate over all the active bullets and check the distance of the bullet to the alien in X and Y. If it's close enough, then set the alien to an explode state, set the bullet to an in contact state, and don't bother looking at any other bullets. At the moment it's not the best collision detection code, but we can improve it later. If we now look at the code to draw an alien, you can see we pass in a pointer to the alien entity, a pointer to the alien image definition, and a pointer to an explosion image definition. If the alien is in a dead state, we use the background colour to erase it, otherwise the foreground to draw it. If the alien state is 20 or higher, we just draw a standard alien image at the entity coordinates. If the alien state is less than 20, it must be exploding, so we draw using the explosion image definition and decrease the explosion state by 1. Finally, we return a pointer to the next alien entity. So here is the working prototype. As you can see, I've added alien bombs, which are the same as bullets but produced randomly by live aliens and set to go down the screen. And there's collision detection for the aliens and the player's rocket. Back at the start I said I wanted to have a general entity structure, and to tidy and formalise that a bit, I want to describe all the offsets used for each byte in the structure, so the code is easier to read and we replace all the magic numbers with more meaningful constants. I've also defined an all-purpose init entity function, and you can see it's a bit easier to understand what's being set in the memory structure. We now have the ability to add extra data for specific types after the base details by allocating extra space at the end. I've added a general move entity method designed to work with all entity types. There's a relative position version and an absolute position version. Both versions call a procedure to calculate the center coordinates once on a move to be used later by collision detection. This uses the entity position and its width and height to set values in the entity structure. Then our collision detection code becomes more accurate, more efficient and easier to read. This version of Pixel Fandango Space Fighter X has a big improvement. Real game changer if you will.
Oh yes, that's very witty.
I've introduced a swirling pattern to the alien's movement. And when one wave is destroyed, a new bigger wave appears. When the game starts, this init flight pattern function is called that populates a lookup table in memory with positional movement data based on a simple equation. The start alien procedure iterates over alien entities to find the first dead one, then reinitializes it at the start of the flight path. The update alien function gets the flight path index, which is an example of an extra field specially for alien entities, and increments it. That index is then used to look up the next position change in the flight path. Because some of the movements are negative and we use integer bytes, we need to do a bit of conversion to a signed number. Then the entity is moved using the relative move entity function. But there's more! This version uses the lower resolution but more colourful graphics mode 1. I've also designed bigger images and a more interesting rocket ship. And I've added some, albeit simple, sound effects. And now, just to prove it, here we have my BBC Master running. Now of course I'm still cheating because it's running on a relatively modern Raspberry Pi hidden inside the old beige box. But here's the code, which is BBC Basic 2 just like in 1983, and it's still using Mode 1 graphics. And there you have an arcade style shoot 'em up written in BASIC and playable too. I'm sure I haven't written perfect code. It's been a long time since I wrote a BASIC program this big and I'm very rusty, but I'm fairly pleased with the result. If you have a PC or Mac, you can use a BBC Basic editor, or even just a general text editor, it makes reading the code much easier. This is the whole thing. It doesn't seem nearly as long or complex on a bigger screen with highlighting. You can even run and debug the code, which is nice. I'm very happy with my simple game. It didn't take too long to write and it's fun to play. I'm sure the code isn't perfect and I might do another video to improve it. I've got lots of ideas. If you like this video as much as this lady clearly does, then please do like and subscribe. Cheers!